Okay, welcome everybody. This is the week 3 webinar. And we have pretty much to do today, but not as hard as last week. I'll let you know that. Last week, chapter 3 is usually what is a tough one for people. Whereas we're doing 2 chapters this week. That sounds scary, but actually the 2 chapters combined are easier than chapter 3. So for most people at least. So let me talk about the plan. I'll always take questions, not just at the beginning, but throughout. That's important. And then after that, I want to give you a reminder of discrete versus continuous variables. So both quantitative, but just, what are they? Because really, we have chapter 4 and 5, and chapter 4 is going to be all about discrete variables. Chapter 5 is going to be about continuous variables. Then we'll look at probability distribution tables. Very important to be able to make a table out of a probability distributions. We'll look at the expected value and the standard deviation when you have a probability distribution table. Then we'll look at something called the binomial distribution. And I don't expect you to understand every word I'm saying right now, but hopefully by the end of this hour and a half or so, it'll make a lot more sense. And then we'll get into continuous distributions. And continuous distributions are important, as she is too. And so we'll look at continuous distributions. And there's one special one that we're going to do because it's the easiest, not because it's the most important, but because it's the easiest, and that's called the uniform distribution. That one will be able to actually compute probabilities just by hand simply. Whereas all the others are too hard. You have to use fancy calculators, which we'll do in this class, but we'll do the calculators. Then we'll look at the mean and the standard deviation of the uniform distribution. And once you have the mean and standard deviation, you can get a z-score, for example. So that is the plan. And I want to note a few things before I get to the main stuff. One is this is week 3, so there's no main exam to do this week. Always good. But there's your project you should be thinking about, pretty deeply now. Some of you have posted your project ideas, which is, very important. And take a look what whether it's you posting or someone else, take a look at what I have put into the discussion board to see what works and what doesn't work and suggestions. And that way you'll... Question?
No.
Question? No? Okay. So again, take a look at that and make sure that you post your project idea. This is about time to do it. And not just, you should post a survey question in words, quote, survey question, end quote. You should also post who your client is, who your population is, also what your sampling technique is going to be. So if you're doing stratified sampling, what your strata will be. If you're doing cluster sampling, what will your clusters be? So that will help get you started. And then I'll give you some suggestions on improving, or let you know, hey, it looks perfect. But usually there's something that can be improved on. Sometimes it's small wording on the question. Sometimes, you just forgot to put in something, like you forgot to say who your client is or something like that. So that is the plan. I want to mention one more thing, and that is I graded the discussion post today. There's 2 big things of grading today. So take a look at my notes on the discussion post. I want to give you a big reminder. And again, most of you are good, but there's a good group. There's a group of you that aren't posting up by Thursday for the initial post. So the initial post has to be done by Thursday. The final post, the reply to your classmate, that has to be done by Sunday. But, so don't wait till Saturday to do your initial post, and definitely don't wait till Sunday night, because then no one can answer it. So very important in terms of discussion assignments. After I graded, I look at, what went right, what went wrong, and there's a group of you that aren't posting by Thursday. It's not that hard to do the initial post. So don't lose points by, making it late. And also if you make it late, then your classmates can't respond to it because they don't have time. So really important. Tomorrow, my plan is to grade your exam one, your week 2 exam. So that's my plan. I decided today I'd put my effort into the discussion, and tomorrow I'll put my effort into the exams. I can only do so much. And today I also teach a lot too. So, those things happen. So you can expect that, I can't tell you what time tomorrow will be done. Depends, but definitely tomorrow. I should have them all done hopefully tomorrow. If not, it'll be Wednesday, but I'm pretty sure it'll be by tomorrow. So are there any questions about anything? A great time to ask. I'm not seeing any. It doesn't mean that you can't ask later, but
I have a question.
Yeah.
How you doing today?
Doing great.
Right on. I'll say hi to everybody. But yeah, so you say you haven't graded the exam yet, right? So the points that we received afterwards, there's still possible points to gain. Did you say?
Yeah. So the way the exam works, and I mentioned it, I just think it was 2 weeks ago, so you might have forgotten already. And that is the first something like 14 questions or so were graded by the computer. And the last 2 questions are written out questions, right? Where you type out the answer in a little box that's provided. The computer can't grade those. Okay, computers aren't quite smart enough to do that. So
yeah, I was wondering, right? Because yeah, they marked them wrong. So I was like, oh man, like
yeah,
how that's possible. But I do remember you saying that. Yeah, okay, got you. Thank you.
Yeah, so that's just the way the computer works. So sorry if the computer's not as nice. But so tomorrow I'll look at it. Now, if you left them blank, then it's already graded, you got a 0, but hopefully you didn't leave them blank. So again, I haven't graded them, so I don't have comments on, improvements, that kind of stuff, because I haven't really looked at them yet. Because I spent today focusing on the discussion. I had to choose one to start with. Yeah, so if you put stuff in, your score should increase. It won't double because it's only 2 questions that are weighted heavily, but still it's 2 of the questions. But it definitely should increase your grade. And again, I'll see how it goes when I grade it. I'm an early riser, so I'll probably start early morning and have a meeting at 10, and then I'll do more after that meeting. Is the plan. Does that make sense?
Yes, sir. Thank you.
Yeah. So it'll look like you did terrible on the exam because I haven't graded them yet, and it just automatically shows a 0, even though that's not true. And that's just the way the system works. Sorry, but I didn't make the system. Okay. Other questions? Good question though.
Are we allowed to use notes during the exams?
Yeah, the rule of the exam is what you're not allowed to use is other people. So you can't call someone or text someone or email someone. That's the one thing that you're on your honor that you're not going to ask anyone else for help during the exam. You can use notes though. Okay. Be careful about just writing down the note for your answer in the last couple questions, because the problem is the question on the test is going to be very specific about something. You have to be writing about that and not just some definition. Does that make sense? The definition will help you, but don't just write the definition down. So that's important, because I know in the past people have done that, and last quarter and the quarter before. But yeah, you're allowed to use notes. So again, memorization is never required in this class. What's required is understanding. Okay, so that's kind of the, whether you like it or not, that's the way I'm going. Hopefully, did that answer your question? Okay, other questions before we move on? Okay, let's move on. And let me remind you, this came from chapter 1, but we're back. And that is a discrete variable. is a quantitative variable. Who remembers quantitative? Very important word in this class. What's quantitative mean?
Number.
Yeah, it means that the answer to the survey question or what you're writing down after looking at the tree or something will be a number and not a word. So first thing, it's a quantitative variable. And the set of outcomes can be displayed as a list. Okay, so often there's like 7 different outcomes. You can write the 7 outcomes. Okay, sometimes there could be an infinite enough, but you can draw ... and it'll be clear. I will let you know, I'm not giving you the formal definition of discrete. Anyone know why? It's the first of many times I'm going to be telling you this, maybe the second of many times, because it's too hard. You have to be a math major for it. And I can't expect you to be math majors. Some of you might want to be one someday, but it's definitely not a requirement in this class. So what I want you to do is kind of understand the idea of discrete. The formal definition is brutal. So just let you know that. If you want to really hear it, come to my office hours, I'll torture you. But I won't do it in class. Okay, so if it's not discrete and it's quantitative, then we call it continuous. So there's basically 2 kinds of quantitative variables. There's discrete, there's continuous. Okay, and again, for a discrete variable, then you can write a probability distribution table. Sometimes it has to go ... though. Okay, so this is something I actually learned when I taught English. I know you probably are surprised I was an English teacher. But I taught English, not the way you think about teaching English, probably. I taught English as a foreign language. So that means I was in Japan and I was teaching English. And one of the things I needed to teach them was some grammar, something that they didn't have. And that is the difference between how many and how much. I don't know if any of you have been to Japan or speak Japanese, but I do. And they don't have that idea, but we do, which is great because the answer to how many will be discrete. Okay, and the answer to how much will be continuous almost all the time. It's not perfect, but 99% of the time that works. So there's lots and lots of survey questions that you can ask with the how many, and there's lots that you can ask with the how much. Okay, so can you think of something that you can say with a how many?
How many answers did you get correct?
A little louder, I couldn't hear.
How many answers on the test did you get correct?
Yeah, how many of the how many of the questions did you get correct on the exam one? There were, I don't know whether it's 16 or something questions, and some you get right, some you don't get right. Does that make sense? Okay, is that clear? Let me give you another one. It's kind of a fun one, and I like to use it this way so you get used to it. And you can put in the chat box the answer if you want. Again, it's all, if you don't want to, you don't have to, because we're not going to do anything with it. But in your family, including yourself, how many siblings are there? And I like this one because I have an interesting answer. Let's see if you can put in the chat box. How many siblings are there in your family? And you can, you don't have to tell the truth, but should be reasonable. Don't say 3 billion. Okay. So you'll notice we're getting numbers, and mine's typically, wow, 12. Don't usually get a lot of 12s. That's cool. Okay, you can't have 0 because I said including yourself. You're alive. So you could have 1. Does that make sense? Yeah, you can have 1. For me, 4.5. So how come? I have a stepsister. She's a half sister. So I call her half, Laura. Yeah, nice woman. So 4.5, but what you can't have is say 4.1357921 siblings, right? It wouldn't even make sense to say that. But you could have 4.5, and that's okay. So you can list all the possible numbers, right? 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. And maybe you can go up to 50 or something. I don't know. I don't know the most number of siblings in the world, but something like that. Okay, you could eventually stop. Does that make sense? So notice you can list all the answers. Do you see how that works? So that would be an example of a how many question. Okay, whereas a how much might be exactly, and so I like to use the word exactly because that reminds us of something. Exactly how much do you weigh? And I guarantee none of you know because of the word exactly. Right? I'm somewhere around 172 pounds, right? But really, I'm probably 172.135289345, blah, 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 right? So you can't list all the possibilities of exact weights because it's a whole piece of the whole kind of number line. Does that make sense? And not just integers or integers and halves. Do you see how that works? So that's one of the main differences between discrete and continuous. Continuous is like a full piece of the number line that includes like all the stuff from here to here, or maybe all of everything. Whereas discrete doesn't have that whole long range because it only includes certain fractions or no fractions. Any questions on that idea?
So continuous is kind of like pi.
Yeah, pi. So pi, you can think of, I mean, pi is just one number, right? But pi is on the number line. And it's got so many decimals, you can't get them all, right? But it's a little more complicated than just pi because pi is just one number. It's more like all the numbers between 0 and pi, or 0 and 5, right? All the numbers on the number line between 0 and 5 would be continuous because the decimal point never ends, right? Okay, so now we're going to do an example. And this is somewhat real life. Okay, a car salesperson gives out a $10 gift to every customer who test drives a car. Does that sound normal? Yeah, that's a typical. Yeah, it's typical, hey, you bring them in, right? That's how you get them to come, right? 12% of all customers who test drive a car purchase a base model of the car, okay, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay. By the way, what do you think the rest do in the real world? What do the rest do? What do most people do?
They don't buy the car.
Yeah, they don't buy the car. They walk off with their $10 gift, right? And as a salesperson, it sucks because you just lost 10 bucks. Do you see that? Okay, that's reality, by the way. This isn't some weird math problem, right? In fact, my brother, when he was in college, he sold cars. He did this. Yeah, now he's a doctor, but he sold cars as a little, college job. So this is the kind of stuff that happens. Okay, so we want to look at the profit. So we want to look at the profit. So what we're going to do, let me go for there. Is we're going to create a probability distribution table. And we're going to look at the values of X that can happen. Now, this is a discrete variable because we can list all the things that could happen with this car sales. Okay. One of the things, I guess that didn't work. Let me go more. There. Okay. There we are. Okay, one of the things that could happen is they purchase the base model. What's the profit for the salesperson?
200.
Hmm?
Total or for just the base card?
The profit for the base model.
200.
Not quite. Because remember, what does the salesperson have to do at the very beginning?
12%.
Salesperson has to give away 10 bucks first,
$10.
right? The salesperson has to give away 10 bucks and then gets 200. So the profit, and this is very important in business, by the way, is revenue minus cost. How much you bring in minus how much you have to spend. So it's 190. Do you see? 200 comes in, but he had to give away 10 bucks. So 190, still good. 190. Okay, what is the profit if the person purchases the deluxe model? My guess is you'll all get this one right now.
290.
Yeah, 290. Because again, they're bringing in 300, but had to give a $10 gift certificate. So 290. What's the profit if the customer just walks away?
0.
Not 0. What's the
No.
revenue minus the
10.
cost?
Negative
It's
10.
negative 10. It's 0 minus 10. Do you see how that works?
Yeah.
So it's negative 10. Right? Any questions on that? Okay, so now in the probability distribution table, and by the way, you can write it vertically or horizontally. Usually do whatever fits on the page. So I made it horizontal so you guys can see it better. But sometimes you'll have X and P of X, and then it'll come down. So what is the probability of a $190 profit? It's given in the question.
0.12.
Yeah, 0.12. So it's 12%. Remember, to turn a percent into a decimal, you need to move the decimal over 2 times, or 2 places to the right, and to the left, and that would be 0.12. Any questions? Let me write it just so you can see it a little better. 0.12. You can do either way. It's just easier to see on the screen. Okay, what is the probability of a profit of $290?
0.08.
Yeah, 0.08. 8%, you move the decimal over 2 places to the left, and you get 0.08. Any questions on that? What's the probability of the loss of $10 of this negative profit? And this is very important in terms of something that we have in the last chapter.
80%. 0.8.
Right. It's going to be 80%, but let me walk you through the steps in case you didn't immediately see it. So you know that the total probability is always equal to what number?
100 or 1.
1. And 1 needs to be equal to 0.12 plus 0.08 plus our P of negative 10. And 0.12 plus 0.08 is 0.2. Maybe I'll even write 0.20 because it's easier to see. And that's plus P of negative 10. Any questions on that? So then 0.2 plus something is 1. And that, if you subtract 0.2 from both sides, you get 0.8. 0. I'll write 80 because then it feels better. I don't know. You can go either way. Any questions on how I arrived at that profit and this full probability distribution table? Okay, so if you're ever asked to write down a probability distribution table, then this is what I mean by that. And not even if you're ever, when you are asked, you will be asked to do it. Okay, in a few places, a discussion board for this week, you're going to have to do one. And then on the exam in a couple weeks or almost 2 weeks, that kind of stuff. Okay. All right. So what we want is we want what's called the expected value. Okay. This is a nice table, but we want to think about what does it tell the salesperson? Is this a good plan? Because that's really what this is all about, is you look at the probability or look at the data, and then you make decisions based on it. Okay, so we're going to create what's called the expected value. And what this is, and this is a template, if many trials are done, in this case, in this example, a trial means someone coming and you give them $10 and you let them test drive the car. So if many people come and test drive the car, so if many trials are done, then it is very likely that the average of the trials, and so in this case, it'll be the average profit, because that's what we're interested in, will be very close to the expected value. So I want to note something that's important. Many, likely, average, and close to. Okay, I put those in red. How come? Okay, not hearing it because they're important.
Keyword for the probability distribution.
Yeah, and more importantly, I want to let you know when, not if, when I ask you to interpret this expected value, if you don't have those words in your interpretation, you will lose points. Okay, and as I mentioned towards the beginning, you're always allowed to have notes. So there's no excuse because you got notes. It's not like you have to memorize the words, but you have to know to put those in when you're asked for the expected value. Okay, there are other ways of doing it, but that's it's too confusing for most people if I give you different choices of ways of doing it. But this tends to be the easiest writing. Okay, here is the formula, which you don't need, but I figured I'd show it to you anyway. One thing you do want to know is this letter. What is this letter? We've seen it before.
Mu,
Mu. And mu corresponded to the
mean,
mean. What's another word for mean? The kind of simple word for mean, if you want to tell, a fourth grader?
average.
Average. Okay, so the expected value talks about an average. Kind of an average in the long run. Do you see how that works? So that's why they use often the letter mu, but EV kind of reminds you that we're dealing with expected value. And this is the formula which you're not gonna have to use. Okay, so now, instead of using this formula, I just said you're not gonna have to do it. Any guess on what we're gonna do instead to find the expected value given this table?
Calculate.
Yeah, I'm gonna use a calculator. So I'm gonna go to here. I tried to make it obvious when I created this calculator. What number calculator do you think we're gonna use? What calculator number?
8.
We don't have a normal probability. It's
6.
obvious. Huh?
6.
6. We want the expected value. Does that make sense? It's not a trick
Yeah.
question. It says expected value. So if you want the expected value, then how about the expected value one? Does that make sense? Okay. Number 6 is important, but that's next week, not this week. Okay. And as I warned you, sometimes you'll see it vertical, sometimes you'll see it horizontal. It has to do with fitting on the page. And this time it's vertical because it fits better, it turns out. So then let's go and look. We have 190.12. We have 290.08. And then we have negative 10.80. Any questions so far? Okay, and by the way, if you make a mistake and you did 0.90, it'll warn you, because these have to add to 1 or you can't even talk about it, because the probabilities always have to add to 1. So I did that, and I tried to make it easy. You hit the calculate button. Does that sound easy? So the expected value is 38. Any questions on that so far? So right, EV is 38. Okay, so now the interpretation. So here's what I want to warn you. Do not just write this down if I'm asking you to interpret the expected value, because this is like a general definition. We need to talk about, people looking at cars. Does that make sense? So we need to interpret it based on this particular question, which was a car salesman or salesperson is giving out a gift, and some people buy this and some people buy that. We want to look at the profit for the salesperson. So what we can say is that if many, there's that word many, customers come in and test drive a car, then it is very likely that the average, it's not average of the trials, but average profit per customer will be close to, and not the expected value, but 38, and the units are dollars. Any questions on that? Any questions on writing down the interpretation using this, but then make sure you put it in the context of the question, the car sales in this case? Any questions on this idea? Okay, the standard deviation. Standard deviation, I'm going to round to 2 decimals. Any guess on why? I would either go 2 decimals or a whole number. How come in this case? But definitely not 1 decimal place. I don't know. Not hearing y'all jump in, because this is money. Nobody uses 1 decimal place with money. You do dollars or dollars and cents. You don't do dollars and dimes. That's just not done in America, right? So it's either dollars or dollars and cents for this example, because it's money. It is important to always keep in mind what this is. So let's go dollars and cents, which is $98.47, because you got to round, use the rule of rounding. So 98.47. By the way, is that a big number or a small number, especially considering the average profit? What do you think? Big or small? Is it a big standard deviation or a small standard deviation?
Big.
Yeah, this is a big standard deviation. It's much bigger than the average. So what that tells you is that, first thing, the customer is getting an average profit close to $38. And I'm not a car salesperson, by the way, but let's say it, I don't know, it takes on average a half an hour to show someone, to help test drive the car and to talk to them, right? Well, if the average profit is $38 per test drive, then the hourly wage would be $76 an hour. Is that good money? For a job that doesn't require any education. That's what we're looking at. Okay, that's pretty good. Okay, it's a whole lot more than minimum wage, right? All right, so it sounds like good money, but the standard deviation is very high. So what that tells you is, yes, they're getting good money, but The standard deviation tells you kind of the variation in how much they're making. So what this says is that even though it's a, good average salary for the long term, there will be days at which, or definitely hours at which the salesperson isn't making any money. You see that? Is losing money. So kind of a decision you would make is, if, you might take this job, okay, if you're looking for a job and you're not thinking about a career with big education or anything, but just looking for a, quickie job, you might take this job, but you better have money in your bank account. Because you might come home tomorrow, not have made any money today. Do you see that? And now you're screwed because you can't afford food. Because you just actually lost money on that day instead of made money. Do you see how that works? So that's how you can use this expected value and standard deviation. So, it would be a high hourly wage, but with high risk. Any questions on that? There's good days and bad days. Okay, so let's look at another example. And I think I'm going to do this one a little quicker. You have been offered a life and dismemberment insurance policy, okay, that costs $1,000 per year. Okay, you've all seen this kind of stuff, right? Okay, the policy pays the heirs $100,000 in the event of death. Okay, obviously you don't get any money because you're dead, but if you have a child or something, or whoever your heir is, and $50,000 in the event of dismemberment. By the way, if you don't know this word, that's like, if you, I don't know, cut your hand off or something, or run into an accident and end up blind. That's dismemberment. Does that make sense? So some like horrible, not deadly accident, but something that really zaps you. Okay. The actuaries, that's the person who has to make the decision on prices and stuff, have determined that you have a 0.3% chance of dying this year. Okay. Every year you have a chance of dying. Sorry about the bad news, but it's called life, right? Okay. And a 0.5% chance of dismemberment this year. Find the expected value and standard deviation. Interpret the expected value, then explain why the standard deviation might indicate that it still might be a good idea to purchase insurance. Okay, so let's go and do it. Okay, so let's look at the things that could happen. Well, you could die. If you die, then the profit is $99,000. It's $100,000 minus the $1,000 you paid that year. So we have a $99,000. Okay, you could get dismembered, and that'd be $49,000. Okay, because again, you get $50,000, but you paid $1,000. Or maybe you didn't die and you didn't get dismembered. What's your profit? What's your profit? Not $150,000. Your profit is negative $1,000. You paid the insurance company $1,000 and they give you nothing back. Okay. By the way, which one is better? Which would you rather have? I hope you all have the same answer.
The death.
Hopefully not. Okay, then you need to talk to a counselor. Hopefully the negative 1,000. Hopefully you don't want to die. Okay. Yeah, no. Hopefully we all would rather have negative 1,000. And hopefully you don't want to like get blinded or something, right? So the negative 1,000 is what you want. I know it sounds weird, but with insurance is a little weird when it comes to, rewards and punishment and stuff. Okay. So now let's get the probabilities. Okay. We had a 0.3% chance of dying. By the way, that's 0.003. We had a 0.5% chance of dismemberment. That's 0.005. And then the chance of not dying and not getting dismembered will be 0. Well, it's 1 minus these. If you add these up, you get 0.008. And if you do 1 minus 0.008, you get 0.992. Any questions on that?
Why are there 2 zeros? Like-
It has to do with the percent. So
Okay,
if you take this decimal place right here, and you
yeah.
move it there, there's a 0 to
Oh,
the
you're
left.
moving it to the left?
You always move to the left. So the first time that 0 happens, the second one, a new 0 comes in.
Okay,
And that's how changing decimals to changing percents to decimals works. Okay. Want to make this a little bigger because it looks weird. Any questions on my distribution table? Okay, so now I'm going to go here. And I think the easiest thing to do is to refresh. What that does, it clears everything out. And that's what I want. I don't want those numbers anymore, the old ones. And we have 99,000, 49,000, negative 1,000. And the probabilities were 0.003, 0.005. And 0.992. Any questions so far? Scroll down, hit calculate, and there's my expected value, and there's my standard deviation. Okay, so the expected value of negative 450, do you think this is a good buy when it comes to, what the expected value is telling you? Okay, so you're only going to buy life insurance the one time, right? You can't do thousands of life insurances. You only live so many years, right? Okay, you can kind of imagine many people buying life insurance. Then it's likely that on average, so it's very likely that the average amount of loss per person is $450, is close to $450. Okay. But the standard deviation is huge. I'll go to the nearest dollar, $6,496. So when do you think you'd want to buy life insurance based on this information? Any thoughts? Okay, it's if you dying or being dismembered would be a financial disaster to somebody. So that would be, let's say you had, a 5-year-old child and you are the breadwinner in the family. Then that might be a time to buy life insurance, because even though on average it's a bad bet, if this happens, it could be a complete disaster for the child. Do you see that? So that's the reason to buy life insurance. If you have no one that's, if you don't have any interesting heirs that you care about, don't buy life insurance because it's just negative.
Taylor?
Yeah.
What says the actuaries have determined 0.3% chance this year? And
Yeah, this is for this year.
And 0.5% chance this year. In the paragraph, it says this year twice.
This year, 5%. One's dying and one's dismemberment.
Oh, gotcha.
Yeah, so they're different things. Yeah. And we're going to assume both don't happen together. End of the year, they pay. If you die, they give you more than if you're dismembered and then die. Okay. Any questions on this example? Okay, there are a lot of examples on expected value. Just to let you know, one that I used when I turned 21, any guess? Something very important about turning 21. And it wasn't drinking, by the way. Okay, it was gambling in the casinos with card counting. And I was able to make a positive expected value for blackjack with my card counting technique. And because of that, I would spend all day long in the casino and I never lost. And I usually made several hundred until they told me they'd kill me, and then I never came back. and they were, by the way, they really would have killed me if I came back. It wasn't just a threat. That's how it was in those days. Things are different now. Okay. All right, let's go to the next topic. The next topic is a binomial distribution. Okay. And by the way, we're still in chapter 4. Chapter 4 is a little longer than chapter 5. Okay, the binomial distribution, it comes from multiple independent trials of a yes-no type question. And it measures the number of yes answers. Okay, so it looks at the number of yes answers and the number, and that would be binomial. So there's lots of examples. Let's suppose that you're a nurse. And you're working with patients. And what you want to find out, let's say you're working with cancer patients or something, a nurse or doctor. And what you want to say is, of your patients, how many of them are going to die of cancer when they come in? Okay. And there's a certain probability of dying. Sorry if this is depressing, but I know some of you are thinking about medical care, and this is important. So how many, what percent die? And each person has that percent chance. If you know nothing else, then it's that same percent. They're independent. The second person that comes in has nothing to do with the first person who walks into the, hospital, right? Typically, of cancer. Okay, so that would be binomial. Is, let's say you had, 50 patients a day, then, how many patients are going to die in the next year? That kind of thing. Okay. There are lots and lots of examples. Here's another one. It's also kind of depressing, but not as depressing. Okay, so there have been 142 years in recorded history of global temperatures. Okay. In the next 20 years, if weather is random, find the probability that at least 10 of them will be in the top 10 of the prior 142 years. Okay, so this is a binomial distribution because each year has a probability of being in the top 10. Does that make sense? And you want to see, of those 20 years, how many are going to be in the top 10? Any questions on that? And you're either in the top 10 or you're not in the top 10. All right, so just a letter we use for sample size is 20. We mentioned that last week, I believe. So N is 20 is the letter we use. And that's the sample size. The probability of a yes answer is, yes, by the way, means you're in the top 10. Okay, would be 10 over 142. Any questions on that's why that would be the probability of being in the top 10 out of 142 years? Any questions on that? All right, so we want to find out the probability that at least 10 will be in the top 10. So just a note, and this is very important, at least 10 is X is greater than or equal to 10. Any questions on that? Okay. So I wrote low, high, trials, P, because that's what you're going to need. So to compute this probability, here's what we're going to do. We're going to go back to the calculator menu. And let's see if you can tell me what calculator number. Lots of good hints. What are we talking about right now? And also, I told you we do things in order of the class.
7.
Yeah, number 7, binomial probability. Because we have a binomial distribution. Okay, to be at least 10, the low is 10. Okay. And the high is going to be 20, because if you're anything higher than 10, you're still at least 10. Does that make sense? Any questions on that? Okay, and by the way, I know it doesn't seem like you could have more than 10, but if the first 10 were in the top 10, then the next year could be in the top 10 of the last 147 years is the idea. That's kind of how this is working. The number of trials is 20, because that's how many years you're looking at. Any questions on these numbers? The probability was 10 over 142. And to get that, we're going to need the scientific calculator. You can go 10 divided by 142. And that's this messy number. I like copy and paste. Any questions on what I just did? And calculate. Okay, and what did it give me? Right? What's the probability of having at least 10 in the top 10?
Zero.
Right, 0. Okay. And what this really means is that something so close to 0, it has too many decimal places before you even get to a non-zero number for the calculator to handle it. Okay. So it's pretty impossible. Okay. At least practically impossible. Does that make sense? That can happen sometimes. So what does that tell you? Now, if you go back and look at historical records, we've had 10 of the last 20 years in the top 10. Okay, so then you could say something must be wrong, because if the probability is 0, it shouldn't happen, right? So again, this is real. So what's wrong with the argument? This is very typical in statistics. Any thoughts? It's right here. The weather's not random. Okay. Why is the weather not random? What's going on recently? Hopefully you all know this. This is not math, but you should all know what's been going on in terms of weather, temperature. Yeah, climate change. So this is a statistical argument that climate change has happened. Any questions on that? Okay, this is when you're doing research, this is what you do, is you collect the data, you look at the probability, and if you get something that's 0 or super close to 0, then you say something is wrong, what assumptions were made, and this is the one assumption that was made, is that weather's just random, there's no climate change, it's not like now is different than before. Okay, so that was a wrong assumption, now is different than before. Okay, and then you go and look at the chemistry, and you realize that there's something go on, what has changed to make it not random. And the only thing that they found that could possibly change the temperature, globally, in many years, is the atmosphere, is that we're discharging a lot of carbon dioxide and methane. Okay, and that is a very, very clear scientific argument that is really you can't even argue against it because it's science. I mean, I guess you can because some people don't believe in science, but but hopefully you're okay with science. Okay, any questions on this? Okay, so again, I wanted to give you like a real important example. Okay, here's another example. Okay, and there's a bunch. Okay, so as of today, I looked this up this morning, by the way. 73% of all Californians have received at least one dose of the COVID-19 vaccine. Okay, I'm one of those, by the way. I have received lots of doses, by the way. If 15 randomly selected Californians are surveyed, what's the probability that between 5 and 10 of them have received at least one dose? Any questions on the question? Okay, so what we can do is we want the probability that between 5 and 10 of them have received at least one dose. What's the low? This is supposed to be easy.
5,
5. What's the high?
10.
10. Was that easy? It was supposed to be. Okay. We surveyed 15 Californians. So how many trials? 15. Any questions so far? The probability of any particular person saying yes to the survey, I have been vaccinated, at least one dose, is 73% or 0.73. Any questions on that? And calculate. So there's about a 38% chance. Okay, so the answer is 38% chance that between 5 and 10 of these 15 people have been vaccinated. Any questions on that? Okay, what is the probability that at least 11 of them have received at least one dose? So if it's at least 11, what's the low? And if you understand what it says, it's easy. If you don't, you might get it wrong. At least 11. What's the low on that? The smallest number that's
11.
at least 11. What is it?
11
11.
is, yeah,
Yeah,
okay.
11 is the smallest number that is at least 11. What's the biggest number that's at least 11? You're surveying 15 people. Not supposed to be that hard.
15.
15. Can't have more than 15 if you ask 15 people. There's still 15 trials and P is still 0.73. And you get about a 62% chance. Any questions on that example? Okay, so one of the hard parts is interpreting words like at least. Make sure you understand that. Okay, fewer than 10 of them have received at least one dose. What's the smallest number that's fewer than 10 that could happen?
9,
No,
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 1.
not quite
0.
1. 0.
oh,
0 is fewer than 10. It's also less than 1, by the way. And that could happen, right? You have all 15 of them haven't even bothered getting vaccinated. What's the highest number that's fewer than 10?
9.
Yeah, now comes the 9. Still 15 trials and probability 0.73 and about a 20% chance. Any questions on that? Okay, so now, how about exactly 12 have received at least one dose? What's the smallest number that's exactly 12? This is really obvious.
12.
12. What's the largest number that's exactly 12?
12.
12 again. Okay, and same trials in P because that's what we're doing. and about a 21% chances if you round. Any questions on these examples? I think the hardest part is handling these wording like fewer than for some people, or exactly, or at least. So you have to understand what all these different words mean, and there's other words that could happen too. So practice helps. Any questions on binomial before we move to the next chapter? Okay, so let's go to continuous distributions. Okay, so remember continuous means you're not going to be able to make a probability distribution table. You can't list them all, right? So that's not going to happen. But what you can do is you can draw a picture. And this is an example, by the way, of a normal curve being normally distributed, by the way, that is continuous. And it turns out that if you want, say, here's our normal curve drawn out, and let's say you wanted the probability that X was between 1.8 and 2.75. Then you plot 1.8, you plot 2.75, you draw little vertical line segments up to the top of the curve, and then you find the area of this. And the area of this will be that probability. Any questions on that idea? Okay, here's the problem. If it was a normal curve, how many of you know how to find the area? My guess, maybe I'm wrong, usually in a group like this, zero, none of you, of the students, by the way. Braulio doesn't count. Huh? You have to have had not just first or second quarter calculus, you actually have had to have the third part of calculus, or the second semester or the third quarter, or you can't even do it. And even then you'll be crying because it's brutal and you can only get an approximation. Just let you know that. So we're not going to do it that way. But if you wanted something that you could find the area under, what would this curve look like instead of looking like this? What is something you do know a formula for area of something? Area of A? Okay, when you have a piece of something. Looking for one word answer. You learn it like when you're young, probably like 5th grade or something. What area do y'all know how to find?
Where?
What's that? A square, yep. And a little bit more general than a square, but the same idea, is a rectangle. Hopefully you all know how to find the area of a rectangle. Base times height. Do you remember that? Length times width is another way of saying it. That happened when you're young. But that was the area of a rectangle. So if this happens to be horizontal, you end up with a rectangle. And that's why we're going to be using the uniform distribution. So a uniform distribution from A to B, like A might be 1.8, B could be 2.75, is a distribution such that any two intervals of length K that is contained in AB has the same probability of occurring in any interval out, and any interval outside of AB has a 0 probability. Okay, and the picture will always be a rectangle. Okay, this is important. It's new notation for you. So the notation is important. And that is you write X. And then, do you know what this little symbol is? It's on your keyboard, by the way. If you speak Spanish or know how to write in Spanish, then you've all seen it.
Sigma?
It's not sigma. Sigma is a Greek letter. It's the letter in Spanish. If you speak Spanish, it's the symbol above the N in enye. If you don't know any Spanish, sorry. And in English, we use the word we use is tilde. And it typically is like a shift, and then right next to the 1, there's a little tilde on most keyboards. You can look at your keyboard if you're looking at a keyboard. That's a tilde. And I've talked to a lot of Spanish speakers, And they don't have a word for this in Spanish. I was kind of surprised. This little symbol above the enye, the top of the enye. Sorry if my pronunciation's not good. Enye. Then you have U. What does U stand for? That should be easy given this paragraph. Hint, this is in red.
Uniform.
Uniform. So what we say is X has a uniform distribution with minimum A and maximum B. That's what this means. Any questions on reading this? It's going to be especially important next week when we're not looking at uniform distributions. We're going to look at normal distributions. We're still going to use very similar writing. There'll be an X tilde. It won't be U for normal. What do you think it's going to be? Any guess? Not a trick question.
N.
N. Yeah, we use capital N instead of capital U. Okay, so that's just standard notation for statistics. Okay, so here's an example. Suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. Okay, it probably isn't, but I'm just supposing because I want to make a problem. Okay, then the first thing is you write X, then you write a little tilde, you write U, and then 10 comma 120. Any questions on coming up with this right here from that sentence? Okay, now there's gonna be some parts. Part A, if a randomly selected student who used a math tutor is observed, find the probability that the student will spend between 30 and 70 minutes with the tutor. Any questions in the question? Okay, so to do this, the very first thing we do is we draw a picture. Just like up here, we had a picture of the normal distribution. Now we're going to draw a uniform distribution. And here, a uniform distribution always is a rectangle. So it's an easy one to draw. The low was 10. The high was 120. Any questions on that? We don't know the height yet, but we will soon. Because we do know that the probability of being, what is the probability of being between 10 and 120? If you're always between 10 and 120. The hint is it's really easy. You don't have to calculate anything. If you're always between 10 and 120, what's the probability of being between 10 and 120?
100%.
100%.
100%. It'll be easier to write it as 1 instead of percents. Percents, the problem with percents is they're really hard to do calculations with. So it's better to use probability 1. Does that make sense? Okay, so we can say the probability of being between 10 and 120 is 1. But 1 is the area of this rectangle. The area formula is base times height. You could do length times width. The problem with length times width is L looks like a 1, so I tend to use BH instead of LW. But that's up to you. Do whatever you like. So base times height. The base is the length of this line right here, this line segment between 10 and 120. To find that length, you do a little subtraction, 120 minus 10. Because that's, if you start at 10, you need to get to 120, then you have 120 minus 10 to go. And the height is h, is what we want to find out. 120 minus 10. You could use a calculator, but you might be able to know that that's 110. Any questions on that? Times h, and that was equal to 1. I'm just rewriting the 1. And now very basic algebra, if you have a number times h equals 1, you can divide by that number and get h equals 1 over 110. Any questions so far in getting the h? Okay, so now that we know h, we can answer the question. That was our first step, was to get h. The question is, what is the probability of being between 30 and 70? So now I'm going to draw the next picture saying we want to say, what's the probability of being between 30 and 70? So we want this area, the area of this smaller rectangle here. Any questions on that? Okay, so let's do this. There, that way we can see it on the screen. So the probability between 30 and 70 is base times height. And it's now this base here. This base from 30 to 70 is 70 minus 30. Times the height, which we already calculated was 1 over 110. And that's 40 over 110, which is 4 over 11. You put it as a decimal if you want. So whatever the computer's asked you to do is what you need to do. If it says write as a fraction or reduced fraction, 4/11. If it said write as a decimal, then it's whatever that number is. Any questions on that? Okay, so the next question is, let's see if we can find the first quartile of the time that students spend with a math tutor. Do you remember what the first quartile, in fact, maybe I'll even write comma Q1, because that was the first quartile in symbols, for the time that students spend with a math tutor. So the first quartile, what that means is it's a number here that we don't know the number yet, but what we do know is that the area or the probability of being less than that number is 25% or 0.25. That was the definition of the first quartile, is 25% is less than that number. Okay. Any questions on that? So now we got to do some math. Okay. There's going to be a little bit of basic algebra, but we're going to have to do it. So what we can say is that the area is 0.25. So here's my 0.25 area, and that's the base times the height, BH. The base is, remember, if you want to go from 10 to x, it's a subtraction. It's x minus 10. So x minus 10 is the base. Anyone lost there? Okay, the height, that's h, that's 1 over 110. We've already figured that out. Okay, so let me not put this in now, but I'm going to put it in a minute. Okay, that's equal to 0.25. Right, that's just, I just rewrote it over here. And if we want x by itself, the first step is to multiply by 110 to get rid of this 1 over 110. So now I'm going to multiply by 110. And that will cancel the 1 over 110 out. So I get x minus 10 is 0.25 times 110. So then if I want x by itself and I have x minus 10, I add 10. And you get x equals 0.25 times 110 plus 10. And calculators are good for that. You put it in calculator, you get 37.5. And there, 37.5 will be the first quartile. So it's a lot of steps. Any questions at all on this example? Any questions? So I want to slow down a bit because this was more complicated than anything I've done today. Yeah, I actually had to do some algebra. You know, nothing more than beginning algebra, but it's still algebra. Any questions? Okay, so it says no questions. Let me move on. I am going to, I don't want to go through all this. I'm going to jump to the last bit of today. Okay, and that is something very important. And there's a big theorem. And that is if x is uniformly distributed between A and B, then what's this thing mean again?
Mean.
Yep. Yeah, this thing mean again. It's the mean, and it's pronounced mu. So the mean is A plus B over 2, which makes sense because it's just the average of the low and the high. If you take the average of two numbers, that means add them up and divide by 2. So the mean is going to be a plus b over 2. What's this guy? What's that one represent?
Standard deviation.
Yep, standard deviation, very important. Okay, the mean, you could maybe guess that it was the average of the low and the high. I would be like shocked if anybody you would guess this. It's the square root of b minus a quantity squared over 12. Okay, and this is a formula, and I'm going to say this a lot in this class. Trust me, sound good? Okay, the only way I could even do this and explain it is with calculus. And we're not going there. Sound good? But you can trust me that this is it. And do you need to memorize this, by the way? No, you don't need to memorize anything in this class. But what do you have to have? You have to have this somewhere available while you're doing your work. You have to be able to refer to it. Does that make sense? So if you ever asked for standard deviation and you had a uniform distribution, then this is the formula you're going to use. Any questions on that? Okay, so very important theorem, and it's beyond this class to even explain why it's true for the second part especially. All right, so far so good. So now for an example. All right, so suppose that the number of ounces of water that people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces. And that the number of ounces of water that students use to fill their bottles in the drinking fountain, okay? If you know Lake Tahoe Community College, one of the wonderful things we have is we have a bottle filler. I use it all the time because I use a water bottle. And I fill it up and then I have it in my office and I have as much water as I have for a while. Usually lasts me a day or two. So, you know, so there's two choices. You can fill your whole bottle or you can just turn it and start drinking. Okay. So if you turn it and start drinking, it's uniformly distributed between 1 and 8 ounces. But if you're going to fill a bottle, then it's 4 to 16 ounces. Okay. Okay. You watch Thorne take a 2.5 ounce drink out of the drinking fountain. And Preston fill his water bottle with 5 ounces of water before he runs off to class. Okay. By the way, just for fun, when I wrote this, Thorne and Preston were my students. So that's where the names came from. It was a lot of years ago, but the nice thing is math never changes. But my students' names do. Okay. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Okay. So if you want to find out how unusual something is, what do we need to do? The hint is this came in chapter 2. What do we need to find? What's a measure of how unusual something is? Not seeing it. It's very easy to type. It's one letter. You could type in more too, but one letter usually does it. Yeah, Z. Okay. And you can type in more like you did, Z-score. So we can find the Z-score to see how unusual it is. Does that make sense? But to find the Z-score, what two things do we have to find? What two things do we have to find the Z-score? There's a formula.
Is it the mean and standard deviation?
Yep, the mean and standard deviation, but hey, now we have formulas.
Yeah.
Okay, So we need to find the mean, the standard deviation, so that we can get the z-score, okay, for both Thorne and Preston. Do you see? Any questions so far? Okay, so I kind of did it. It's a little messy, but I'll talk through it slowly. You know, even though I wrote it out, I want to go slow. Okay, so the goal is to find the z-score. And this is an important formula that z equals x minus mu over sigma. This isn't new, but you know, it happened in chapter 2. I want to give you a little reminder that's kind of important. And that is when you're doing this on a calculator, if let's say x was 2, mu was 1, and sigma was 3. If you type in your calculator 2 minus 1 divided by 3, just like that, that's wrong. How come?
It would divide first, I think, or something like
Yeah,
that.
it would divide first. And you don't want to do that. You have to make sure that the x minus mu needs to be in parentheses when you put in your calculator. So it's kind of hidden in the formula. You don't see parentheses on that x minus mu, but there's hidden parentheses there. So don't forget to, make sure that the x minus mu is in parentheses before you divide by sigma. Does that make sense? So that's just a note. I'm saying it because a lot of people make that mistake. So hopefully you're watching this and you're not going to make the mistake. Sound good? Okay, so now we're going to start working everything out. So first, Thorne's x was 2.5 because we watched Thorne take 2.5 ounce drink out of the drinking fountain. Okay. Okay, so his value, it's not an average, it's not a standard deviation, it's his value. His x was 2.5. Mu, the formula again, is a plus b over 2. Okay. And for Thorne is just drinking. Okay, not a water bottle. And we have between 1 and 8 for the just drinking. So A is 1, B is 8. So now when we go to the formula, A is 1, B is 8. So we do 1 plus 8 divided by 2. Which you could use a calculator or do it in your head, however you want. You get 4.5. Any questions on finding mu? Okay, now we got to find sigma. Sigma again is the square root of b minus a quantity squared over 12. So we're going to do square root. B was 8, a was 1, so we get 8 minus 1 quantity squared divided by 12. And then calculators are good. Okay, not a fancy calculator, just the regular old calculator will give you the 2.02. Okay, and if you're in the fancy calculator that I created, remember there's always that button at the bottom for just regular calculator, and then you can put this in. There's a little square root key and everything. Any questions on coming up with sigma or mu? Okay, then we take the z-score. Well, z is x. X was 2.5, so it's a 2.5. Mu was 4.5. So there's a minus 4.5 because it's x minus mu. Sigma is 2.02. So this says over sigma, so over 2.02. Okay, and this is approximately equal to -1. It's not exactly -1, but it's within a decimal. It's pretty good. Any questions on that? By the way, is this an outlier? Is Thorne's drinking an outlier?
Yes.
One more guess.
No.
No, outliers have to be beyond 2 or beyond -2. And -1 is closer to 0 than -2. Do you see? So it's only 1 away from 0. You need to be at least 2 away from 0. Okay. So it wasn't a trick question. It's just that's the definition of outlier. So it's important that you have that definition. And important for your project, by the way, because you're gonna have to talk, you're gonna have to do that. And you have to decide if you have outliers or not. So you can look at the max and the min, for example, and maybe more. Okay, then we got to go to Preston. Okay, Preston filled his water bottle with 5 ounces of water. Okay, so Preston's X was 5. Any questions on that? Notice he's not just drinking from the fountain, he's filling the bottle. So Preston's filling the bottle, and for filling the bottle, it's uniform between 4 and 16 ounces. Any questions on that? So now we plug in 4 plus 16 divided by 2. This one is not too hard to do in your head. 4 plus 16 is 20. 20 divided by 2 is 10. Okay, but you're always allowed a calculator. Okay. Sigma, on the other hand, good luck doing it in your head. It'll be 16 minus 4, quantity squared over 12, take a square root of it. Okay, I could probably do 1 decimal place in my head, but good luck. So calculators are really good for this. And I got 3.46. And again, not a fancy calculator. This is just your standard any calculator. Okay, but again, we can always go over here and pop it in using this stuff. And notice this has a square root button to make life easier for you. Okay, so now we find Preston's z-score. Preston's z-score will be Preston's x value, which is 5. There's a 5. Minus Preston's mu, which was 10. There's minus 10. Divided by Preston's standard deviation, which was 3.46. So it's 5 minus 10 divided by 3.46. Any questions on the z-score? Put it in a calculator, because you certainly don't want to divide by 3.46 in your head or by hand. So use a calculator and you'll get negative 1.45. Is that an outlier?
No.
Yeah, still not an outlier, because it's only, 1.45 away from 0, and you got to be at least 2 away from 0. Okay, so now we have to decide which is more unusual. This is where you have to understand z-scores. Thorne's z-score is -1. Preston's z-score is -1.45. Which is more unusual?
Is it negative 1.45?
Yep, -1.45, because that's farther from 0 than -1 is. Do you see? So we can say that Preston water usage is more unusually, and notice it's small because negative means that you're on the negative side, you're on lower than average, right? So Preston's water usage is more unusually small, even though neither are outliers, right? But Preston's more unusually small than Thorne was. Any questions on that? Even though Preston used more water. So it's not who used more water, it's who was more unusual in the category they're in. Do you see how that works? Any questions at all on this example? Okay, so notice we've now talked about the discrete distributions, and those you can do a table, find the expected value, find a standard deviation, and interpret it. And we looked at continuous distributions, and those you can't do a table, but you can draw a picture. You can at least do that. And if you happen to be uniform, you can say it's a rectangle and I know how to find the area of a rectangle. If it's not uniform, good luck without my calculator, which we'll learn how to use later, not today. But if it is uniform, then we can use the area equals the base times the height. and area is a probability. Any questions on that? If it's uniform, we have those two big formulas, and that is the mean is a plus b over 2, and the standard deviation is the square root of b minus a squared over 12. Any questions on that idea? Okay, you may not believe me, but most people find doing all of chapter 4 and all of chapter 5 easier than just doing chapter 3. So it might be scary to have 2 chapters, but it's actually the opposite. If you have 2 chapters, you should realize it's not going to be that bad. Every problem is going to be real similar to one of my examples. Does that make sense? That was not true for chapter 3, right? There are plenty of exercise problems that were like nothing like any of my examples because there's just too many types to go over all of them. But here, there's really only the expected value type, the binomial type, the uniform using this kind of rectangle and area formula. And then there's a uniform using the mu and sigma formula. And that's it. It's just those types. You learn how to do those well, then you can do this whole chapter without a problem. Okay. There's going to be some wording in the expected value you got to remember. So that is the main stuff. So secret word. Secret word is binomial, because a big part of today, kind of the middle of today, was the binomial distribution. That's when you have yes, no answer. You're looking at a bunch and you want to say how many yeses were there and what is the probability of that many yeses. It could be that many, or at least that many, or fewer than that many, or between that many, and some other many. So that's the binomial distribution, which is the secret word for today. So that is pretty much everything that I planned on doing today. I want to remind you again, chapter 3 and 4 aren't that hard, but what should you be working on right now this week?
The project.
Yeah, the project. And the project's a lot of work. So make sure you put some time into the project this week. It sounds hard to have 2 chapters, but actually it's not that bad. Usually, like by week 10, no one complains that chapter 3 and 4 are what got them. They do complain about 3 though. Okay. But chapter 4 and 5 are not the ones that people complain about. 6 is not either, by the way. So that's the good news. Next week is kind of an easy week. So that's where you're really doing the project, like the full write-up of your project. Should be you're thinking about it next week, starting to think about it at least. Okay, at least getting the data. Okay. So I'm going to stop the recording.